Good day everyone. In this video, we're going to talk about definite integral. So definite integral, the integral expressed as the difference between the values of the integral of specified upper and lower limits of the independence variable. So we will formally define the definite integral and give many of the properties of defined integrals. Let's start off with the definition of a definite integral. So, definite integral given a function of f of x that is continuous on the interval a and b, we divide the interval into n sub-intervals of equal with x, and from each interval choose a point x sub I. Then the definite integral of f of x from a to b is antiderivative of b and a f of x dx is equal to limit of n to infinity, I is equal to 1 to n, f times x sub I to the equal width of x. So the definite integral is defined to be exactly the limit and summation that we looked at in the last section to find the net area between a function and the x-axis. Also note that the notation for the definite integral is very similar to the notation for an indefinite integral. The reason for this will be apparent eventually. There is also a little bit of terminology that we should get out of the way here. The number a that is at the bottom of the integral sign is called the lower limit of the integral, and the number b at the top of the integral sign is called the upper limit of the integral. Also, despite the fact that a and b were given as an interval, the lower limit does not necessarily need to be smaller than the upper limit. Collectively, we'll often call a and b the interval of integration. Let's work a quick example. This example will use mainly the properties and facts from the brief review of summation notation in the extras chapter. So, we have an example here. Using the definition of the definite integral, compute the following antiderivative of 2 and 0 x squared plus 1 dx. So first, we can actually use the definition unless we determine which points in each intervals that we'll use for x sub I. In order to make our life easier, we'll use the right endpoints of each interval. From the previous section, we know that for a general n, the width of each subinterval is equal x is equal to 2 minus 0 over n is equal to 2 over n. The subintervals are then 0 and 2 over n, 2 over n and 4 over n, and 4 over n and 6 over n. So, as we can see, the right endpoint of the nth subinterval is x sub I is equal to 2I over n. The summation in the definition of the definite integral is then I is equal to 1 to n f of x sub I. X is equal to I equals 1 to n of f times 2I minus n times 2 over n. And then I is equal to 1 to n of 2I over n to the power of 2 plus 1. And then I is equal to 1 to the n times 8I squared over n cubed plus 2 over n. Now we are going to have to take a limit of this. That means that we are going to need to evaluate this summation. In other words, we are going to have to use the formulas given in the summation notation review to eliminate the actual summation and get a formula for this for a general n. To do this, we'll need to Recognize the n is a constant as far as the summation notation is concerned. As we cycle through the integers from 1 to n, in the summation only I changes, and so anything that isn't an I will be a constant and can be factored out of the summation. In particular, any n that is in the summation can be factored out if we need to. Here is the summation evaluation. I is equal to 1 to the n of f is equal to x sub I. X is equal to I is equal to 1 to the n of 8i squared over n cubed plus I is equal to 1 to the n of 2 over n. Next is 8 over n cubed, and I is equal to 1 to the n of I squared plus 1 over n of I is equal to 1 to the n of 2. So it is equal to 8 over n cubed times n plus 1 times 2n plus 1 over 6 plus 1 over n times 2n. Next is 4 times n plus 1 times 2n plus 1 over 3n squared plus 2. And then 14n squared plus 14n squared plus 12n plus 4 is equal to 3n squared. We can now compute the definite integral. The anti-integral of 2, 0, x squared plus 1 dx is equal to limit of n to infinity, I is equal to 1 to n of f times x sub I of x. And then the limit of n to infinity is 14n squared plus 12n plus 4 over 3n squared. And we have 14 over 3. We've seen several methods for dealing with the limit in this problem. This is how we compute or how to solve definite integral.